In this lesson, we're going to take a look at arithmetic sequences again. By the end of this lesson, you should be able to write the explicit formula for an arithmetic sequence and find any term in the sequence using that formula. In the previous video, we talked about the recursive formula, and the recursive formula being a formula where you use the previous term to get the next term. But there is another formula that we can use, and that formula is called the explicit formula. The explicit formula uses the first term in the sequence, and it uses your common difference to find any term in the sequence that you're looking for. So you don't have to necessarily know the term that comes before it. This is especially helpful when you're wanting to find terms that are farther down the line in the sequence, such as the 100th term, or the 1000th term, or the 1,000,000th term, where you don't necessarily want to have to go and find all of those terms that come before it. This is what the explicit formula is going to be useful for. The explicit formula is a sub n, so whatever term that you're looking for, equals a sub 1, the first term, plus the common difference times n minus 1. So the term that you're looking for minus 1. The difference between the recursive and the explicit formulas. Remember that the recursive formula uses the previous term to find the next one, so you must know the term that comes before the term that you're looking for and the common difference. This is good if you're looking at numbers that are on the lower end of your sequence, or if you're wanting to list out the first few terms in your sequence. The explicit formula uses the first term, so there's the difference there. Recursive uses the previous, explicit uses the first term, and it uses the first term to find any term, the nth term, any term in the sequence. And n is that position that's in the sequence. In the explicit formula, a little mnemonic that I like to use to help distinguish between explicit and recursive is in the explicit formula there's an x in the word explicit. There's an x, and when we think about that x, it kind of looks like a multiplication sign. So when we see the word explicit, we should be thinking that we're going to have to multiply in our formula, where recursive we're just adding. When we look at word problems, you have to be really careful with word problems. In a word problem, you're going to identify the first term. To identify the first term, you're going to need to spot the initial value, so the starting amount, and then you're going to need to add the common difference to that. The reason being is because this is a linear relationship as well, and when we think about linear relationships, that initial value is at 0. And when we think about arithmetic sequences, our first term is at 1. So if you're looking at a word problem to identify the first term, once you've identified the initial value, you're going to add the common difference to that so that you get to the first term. And you're going to look for that common difference. You're going to look for that pattern of addition or subtraction, and that's going to give you that common difference. And then you can begin to write your equation that a sub n equals a sub 1 plus d times n minus 1. And then remember, when you're answering the question, because it is a word problem, to make sure that you're answering the question in a complete sentence, that you're not just putting a number down, but that you're explaining what that number actually means or represents in that particular problem. Okay, so let's review a couple things when we're writing an explicit formula for the nth term of a sequence. First thing that you're going to do is you're going to find the first term. You're going to find a sub 1. Then you're going to find the common difference. You're going to find d, that common difference. Then you're going to identify what position are you looking for. Are you looking for the 99th term? Are you looking for the 212th term? What term is it that you're looking for? And then you're going to plug in the values. You're going to plug in the values for a sub n, okay, the term that you're looking for a sub 1, the first term, for the common difference, and for n. You're going to plug in values for all of those values, and then you're going to simplify or evaluate it to get your answer. Okay, let's look at a couple of examples. So we want to write the recursive definition for the explicit formula. So here we're given the explicit formula. We're given a sub n equals 4 minus 5 minus 1. So remember that our recursive formula that's up here is this top one right here. And if you recall from the previous video that the only thing that you really need for the explicit formula is that common difference. So here our common difference is minus 5. So our common difference here is minus 5. So when we're writing our recursive formula, we're taking the common difference from out of here, and we are replacing it, or we're moving it to our recursive formula. So our recursive formula for this one would be a sub n equals a sub n minus 1 minus 5. And 2, we want to write the explicit formula for the recursive. So for the explicit formula, remember that you're specifically going to need the first term and this common difference. Now you can put the common difference at the end, or you can put it in front. We like to write it in the front just because it's a little bit clean and a little bit nicer when we want to evaluate. So we're going to write our explicit formula. So we're going to start off with a of n. Okay, that part's not changing. Equals, we need the first term. So I'm going to go ahead and write out my formula here. Okay, so we need our first term. So our first term here is negative 2. So they give us our first term, so that's negative 2. So negative 2 plus, we need our common difference. We get our common difference from right here, so that plus 6 times n minus 1. So the only two things that we're really going to replace in our explicit formula when we're writing a generic formula is the first term and the common difference. Okay. Given the first term and the common difference, we want to find the first 5 terms. We want to write the sequence in explicit form, and then we want to use the explicit form to find the indicated term. So we want to find the first 5 terms. We're given the first term, which is 9. We know that our common difference is 8. So if we know the common difference is 8, we're just going to follow that pattern. So 8 from 9 would be 17. 8 from 17 would be 25, and then 8 from 25 would be 33. And then we need one more, because I think we're doing the first 5. So then 8 from 33 would be 41. Okay, so there's our first 5 terms in the sequence. We want to write the sequence in explicit form. So remember, our explicit formula is this a sub n equals a sub 1 plus common difference times n minus 1. So we need our first term, which they give it to us. They say our first term is 9. So 9 plus our common difference, which is 8, times n minus 1. And then we want to use this to get our 14th term. So anywhere where there's an n, because we're looking for the 14th term, is where we're going to write 14. So for the 14th term, we're doing 9 plus 8 times 14 minus 1, which happens to be 13. So we have 9 plus 8 times 13, which is 104. Plus 9, and when you add that, that gives you 113. So we can see that our 14th term in our sequence would be 113. Okay. Here we have a word problem. Remember that when we're writing the word problem, that we need to look at the initial value, and then we need to use that to get our first term. So we have the local radio station had a contest where listeners could win money. The contest started with $1,000, and 97 was added every time the previous caller answered incorrectly. how much could the 18th caller win? So remember that we're writing our arithmetic sequence, which is a sub n equals a sub 1 plus our common difference times n minus 1. Alright, so we need the first term. The first term is not 1,000. 1,000 is the initial value. So if I want the first term, I need to take 1,000 and I need to add my common difference, because we know that 97 was being added each time, so that's our common difference, and I need to add it to the 1,000. So our first term is actually 1,097 plus our common difference, which we know is 97 times n minus 1. Now, once we have this whole part set up, then we can now use it to find what the 18th caller would win. So, we would need to look at how much money there would be after the 17th caller. So the tricky thing here is that because it's added after the previous caller answered, we don't want to plug in 18, because 18 would give us the amount after the 18th caller called in. And so we actually need to take a look and go back to the 17th caller. So here we would plug in 17. So we have a of 17 equals 1,097 plus 97 times 17 minus 1, which would then change to 16. If we're multiplying those, if we change this to 16 and multiply, what we'll end up with is 1,552 plus 1,097, following order of operations. Remember, multiplication comes before addition. Then add those together and you get 2,649. Remember that when you're answering this type of problem, because it is a word problem, we want to make sure that we answer it in the form of using words. So what you would say is, the 18th caller could win $2,649. Okay, I'm going to skip that one. I'm going to skip that one. Okay, before watching the next video, what I would like for you to consider is what an arithmetic sequence, or what an explicit arithmetic sequence helps you find. As usual, hopefully you found this video helpful. Please subscribe to the channel so that you are getting updates when new videos are being loaded in. Have a good day.